My name is Sven Buda and I work on the GALAH survey. The GALAH survey, which stands for Galactic Archaeology with Hermes, is really trying to figure out how the Milky Way formed and evolved. And we're using stars as kind of a time capsule to figure out if stars that have been born together share the same chemistry, and then use that to really trace back the history of the Milky Way. When we observe the light from the stars, split it up into the different wavelengths, we can basically extract from absorption lines how abundant these elements are, and we can basically get a signature, a chemical composition signature of the stars. Basically, the idea is similar to stellar DNA.
My name is Amanda Karakas. I'm interested in where the elements came from. So I'm looking at how stars make elements and then how they can be dispersed within the galaxy. This is linked directly to what GALAH does because they're observing elements in different locations in the galaxy, so we're hoping to tie their observational data to my theoretical models. We've looked at the production of heavy elements inside stars. We have found, for example, surprisingly, that there might be a different nucleosynthesis pathway that makes, a different way of making elements, really heavy elements inside stars than what was thought of up until now. So we think there might be something, a process that occurs in low mass stars, so stars like our sun, that makes heavy elements, and it's really only been around for the last few years. So with a student who's also involved in ASTRO 3D, we're looking at how these elements can be made.
So one of the big challenges that we're facing is that we can only observe a really limited number of stars, up to 1 million. And we have a theory that basically tells us this should be enough to find disrupted clusters of stars that have been born together. But so far we're still observing, we're still analyzing, and we're basically developing the techniques to actually find stars that have been born together. We have already observed up to 800,000 stars. The aim is to publish as many stars as possible every year, and we will publish this year 650,000 stars and their element abundances for the community to work with. We're using the Hermes Spectrograph on the Anglo-Australian Telescope, which allows us to really observe high-resolution spectra and really disentangle different absorption lines within a spectrum to really estimate abundances as precisely as possible. I was personally involved in a lot of very exciting research going on as part of the GALAH survey. The one thing I think is really interesting is one of the big problems that we currently have with some of the elements. One of the trickiest elements, I would say, is lithium, because lithium is easily destroyed in stars. And one of the problems that we're currently still facing is we can calculate how much lithium was very likely produced during the standard Big Bang nucleosynthesis, so at the very beginning of the universe. And then we can measure it in the oldest stars, but it doesn't match.
My name's Ella. I've just finished my honours project. I submitted yesterday actually. I had 2 projects for my honours thesis. One of them was looking at getting all the stars in the sky and figuring out how much lithium abundance is in them. Lithium is the 3rd element on the periodic table. It is the first metal, or what astronomers call metal, and basically it's the only element that is produced in Big Bang nucleosynthesis, cosmic rays, and stars. This makes it very unique in the fact that we don't see any other elements like this, which means if we understand lithium, we can understand everything in the universe. We understand stars, galaxies, and the formation of the universe.
So GALAH is focused on the origin and evolution of our Milky Way galaxy. So this is a galaxy that we live in. And it's interesting because we see it now, of course, whereas other projects in ASTRO 3D are trying to connect to, they're looking at galaxies at different snapshots in time. So they're looking at how galaxies have evolved in the distant past. So maybe by tying in the really detailed information we get from GALAH, which is a snapshot of the galaxy today, but we see it in really high detail, we can connect it to these galaxies we see at really far distances, but we don't get the same detail. So maybe we can put these 2 together and understand where all the elements came from in the universe. I think I like the collaborative nature of ASTRO 3D. It's a very friendly environment, but it's also doing great science, and it connects well with my science, so it's the perfect fit.
I really like this community here that really we're all part of it, we all do things together, we support each other. This is really something kind of special.